Sometimes the universe sends a message, not in a bottle but as a silent traveler from the stars. On a crisp autumn evening in 2024, humanity received such a message, a visitor named 3I Atlas. It wasn't just a scientific curiosity, it seized the imagination of the entire world. Suddenly, everyone was looking up, reminded that our blue planet is part of a much larger, wilder cosmic neighborhood. The news spread instantly, first among astronomers, then across every news channel and social feed. For the first time in a generation, our divisions faded. We were united by a shared sky and a shared fate. The universe had our undivided attention. Awe, fear, and unity swept the globe. What would you do if something from another star system was heading your way? That was no longer science fiction. The story of 3I Atlas became our story, forcing us to confront our place in the cosmos. Are we alone? Are we safe? What can we do when faced with a challenge from the vast, silent ocean of interstellar space? The universe was asking us to wake up, to look beyond our horizons. This was more than an astronomical event. It was a mirror, showing us our anxieties, hopes, and potential for global cooperation. The arrival of 3I Atlas was a test of our science, our governments, and our spirit. The cosmos was knocking, and humanity was about to answer. What was this mysterious visitor? Astronomers called it 3I Atlas, the third interstellar object ever discovered. The I stands for interstellar. It came from outside our solar system, a true wanderer. The name Atlas came from the Hawaiian observatory that first spotted it. Unlike planets and asteroids, Atlas was just passing through, an outsider in our celestial backyard. At first it looked like a faint, fuzzy dot, but telescopes revealed a glowing coma and a faint tail, an active comet, but not from our solar system. Its speed and trajectory were all wrong for a local object. This was a piece of another world, heading our way. The most alarming part? Its path would intersect Earth's orbit. There was a real, if small, chance of a direct impact. An object from another star system, possibly kilometers wide, could collide with our planet. The implications were staggering. This was no longer just a scientific curiosity, it was a potential global crisis. The world held its breath as scientists scrambled to learn more. What was it made of? How big was it? Would it hit us? Its journey had taken millions, maybe billions of years, culminating in a dramatic encounter with Earth. The story of 3I Atlas became the ultimate cosmic drama. Humanity had a front row seat. Were we watching a spectacular show or the prelude to catastrophe? The answer would soon become clear. Before 3I Atlas, we'd met other interstellar visitors, brief, mysterious encounters. In 2017, Oumuamua arrived, a strange cigar-shaped object tumbling through our solar system. It defied explanation, no tail, yet it accelerated as if pushed by something unseen. Oumuamua left us with more questions than answers. In 2019, 2I Borisov appeared, looking and acting like a familiar comet. Borisov's composition suggested planetary systems like ours are common across the galaxy. These two visitors proved that objects from other star systems do pass through our neighborhood. Oumuamua was the cosmic puzzle, Borisov, the reassuring cousin. They opened a new window into the universe, showing us that interstellar space is filled with wandering nomads. But both were flybys, ships passing in the night. 3I Atlas was different. It was heading straight for us. The lessons from Oumuamua and Borisov were now critical. We had experience tracking fast-moving, unpredictable objects. The previous encounters were the dress rehearsal. With Atlas, the curtain was rising on the main event. The stakes had never been higher. Humanity was about to face its greatest cosmic challenge yet. The discovery of 3I Atlas was a triumph of modern astronomy. It began with a network of robotic telescopes. The Atlas survey in Hawaii flagged the anomaly. Its computers noticed a faint speck moving too quickly on a strange path. The alert went out. Something was different. Observatories worldwide turned their eyes to the sky, refining the object's path. The game changer was the James Webb Space Telescope. Webb's infrared vision revealed the chemical composition of Atlas's coma water, carbon monoxide, and organic molecules in ratios never seen before. This was definitive proof. Atlas was truly alien. Webb's data also measured its size, a behemoth, several kilometers wide. The process was a beautiful example of global scientific collaboration. Automated surveys, ground-based telescopes, and our most advanced space instrument all worked together. Thousands of scientists across dozens of countries shared data openly. There was no competition, only a shared mission to understand this cosmic messenger. The discovery of 3I Atlas showed humanity at its best, curious, cooperative, and innovative. We were united in our quest to understand the universe and our place within it. Once we knew what Atlas was, the urgent question became, where is it going? Astronomers fed every observation into powerful supercomputers, simulating its path. The results were chilling. Atlas's trajectory would cross Earth's orbit on September 19, 2025. Early models showed a high probability of impact. The world's space agencies confirmed the findings. We had a problem. The global response was immediate and unprecedented. The United Nations convened an emergency session. Scientists, engineers, and policy experts from around the world gathered to formulate a plan. The threat wasn't to one country, but to the entire planet. The race was on, not against each other, but against time itself. Even with all our technology, uncertainty hung over the predictions. Atlas was an active comet. Outgassing acted like a tiny, unpredictable rocket, pushing it off course. This non-gravitational force was the biggest source of uncertainty. Every available telescope, from professionals to amateurs, tracked Atlas nightly. Each new measurement narrowed the cone of uncertainty. News would swing back and forth. One week, the impact probability dropped. The next, it rose again. It was a roller coaster of hope and anxiety. Science doesn't always give a simple yes or no. Often it's a probability. The public wanted certainty, but scientists could only say, the risk is real, and it's getting clearer every day. The race to reduce uncertainty became a global obsession. News channels ran Atlas Watch segments tracking the shrinking cone of uncertainty. The fate of our world depended on the subtle dance of gravity and sunlight, and our ability to measure it. As the potential impact day drew closer, uncertainty rippled through society. Global markets swung wildly, people hesitated to make long-term plans. Governments quietly prepared contingency plans, trying to avoid panic. Schools and universities adapted. Physics and astronomy classes surged in popularity. Students analyzed real-time data. Teachers used the event to inspire a new generation of scientists. Museums and planetariums saw record crowds. Socially, the event brought out the best in people. Communities came together, neighbors shared telescopes. But fear and misinformation also spread. Conspiracy theories flourished online. Governments faced the challenge of keeping people informed without causing chaos. Daily press briefings and public service campaigns aimed to educate and debunk rumors. The crisis forced new levels of transparency and cooperation between scientists and policymakers. The world was learning under immense pressure how to navigate a global threat with honesty and unity. Our fate depended not just on technology, but on our ability to communicate and trust one another. The world was on edge, but also more connected than ever. Faced with a credible threat, the world prepared to act. The question shifted: what can we do to stop it? The world's space agencies formed the Atlas Deflection Initiative, a global project with a single goal: nudge Atlas off its collision course. The leading strategy: the kinetic impactor, launching a heavy spacecraft to crash into Atlas, altering its velocity just enough to miss Earth. Another option: the gravity tractor, using a massive spacecraft's gentle pull to shift Atlas's path. Nuclear options were discussed but dismissed due to the risk of fragmentation. International cooperation was breathtaking. The US provided launch vehicles, Europe designed the impactor, Japan and India developed navigation, Russia contributed heavy lift expertise. It was a global project on a scale never seen before. Humanity pooled its best minds and technology to face a common threat. We were no longer just citizens of our countries, we were defenders of Earth. The world united not in fear, but in determination. The mission was set, the countdown began. In the end, global observation paid off. As Atlas drew nearer, data narrowed the cone of uncertainty to a razor's edge. The outgassing became predictable. Final calculations were made. The world watched as the lead scientist announced Atlas would miss. It would pass within the orbit of the moon, a cosmic close shave but no impact. A collective sigh of relief echoed worldwide. The flyby became the most watched astronomical event in history. For a few nights, people everywhere gathered to witness the visitor from another star system. It was a moment of profound beauty and humility. The universe had knocked. We answered with our best science and cooperation, and we were spared. The legacy of Atlas, a renewed sense of ourselves and our place in the universe. We are now safer, more prepared, and more united. The event showed what humanity can achieve together. The stars are not just distant lights, they are destinations. The sky above is our shared celestial shore, inviting us to wonder, explore, and unite.